First question of the test was, which physical quantity remains same in all the types of collisions? Answer is momentum. Momentum remains same in all the types of collisions. Kinetic energy may or may not. Second is, work done by restoring force in a spring is always, it is always negative, because restoring force and displacement, they always act in opposite directions, right? Displacement is towards the direction of applied force. Restoring force tries to bring the spring back to original position. Third question was, which of the following is a conservative force? Answer is gravitational force, and we have derived this article also, so it can't be wrong. Fourth question is, an electron and a proton are brought closer to each other. What happens to potential energy of the system? So potential energy of the system, that will decrease, because in this case, when electron and proton, they will come closer, they will attract each other, right? So the work done in bringing them closer will reduce, because already they are coming closer because of attraction. So we don't have to do so much of work. So that's why work done will decrease, or potential energy of the system is amount of work done, that will also decrease. Fifth question is, the coefficient of restitution for inelastic collision is, it is between 0 and 1. So third option was correct, between 0 and 1. Sixth is, a clay ball of mass m and speed v strikes another metal ball of same mass m, which is at rest. They stick together after the collision. The kinetic energy of the system after collision is what? It is, if you solve after applying conservation of momentum and find kinetic energy after the collision, very easy treatment. It is 1 by 4 mv square. B part was correct. Seventh question, by how much does the kinetic energy increase? By how much does the kinetic energy increase if momentum is increased by 20%? We have done these kinds of numericals. I gave one such numerical as assignment also. So answer was 44%. If you use E is equal to P square by 2m and find percentage error in kinetic energy, it will come out to be 44%. C option was correct. Question number 8. Select the incorrect statement for the given situation. Two bodies with mass m1 and m2 undergo inelastic collision. So incorrect statement was C. When m1 is greater than m2, m2 will move with 4 times increase in its velocity than m1. This was wrong. Whereas option 1, when m1, m2 at rest, kinetic energy transferred will be maximum. This is correct. The bodies will move in same direction if m1 equal to m2, and when the collision is oblique, then there were two options. So third option, C part, that was incorrect. Ninth question, a ball is thrown vertically upwards with a velocity of 20 meter per second. At what height will its kinetic energy be half its original value? Right, very simple treatment it was, and after solving, answer was A part, 10.2. The answer is A part, that is 10.2 meter. 10th question, a bag of mass capital M hangs by long thread and a bullet of mass small m comes horizontally with velocity v and gets caught in the bag. It gets penetrated into it. Then for combined system, bag plus bullet system, what is kinetic energy? You know what is the common velocity? That is mv over m plus m, right? And solving kinetic energy half mv square, you get fourth part, D part, that is correct. That is half m square v square over m plus m. So these were your answers for the test, and 44 students only, they have attempted the test. So you must see what type of questions are there, students. Okay, now let's come back to the exercise. So we were to do question number 24. Up to 22nd we did, day before yesterday, and 23rd I gave you as assignment. Now let's come to question number 24, additional exercise. So I'm going to share exercise with you. See that? Yes. Question number 24. A bullet of mass 0.012 kilogram and horizontal speed 70 meter per second strikes a block of wood of mass 0.4 kilogram and instantly comes to rest with respect to the block. Okay, so understand the situation. There is a bullet coming with certain speed, striking a block of mass, this, and it comes to rest with respect to the block. The block is suspended from the ceiling in this case by the means of thin wires. So it will not move, it will get raised to certain height because it is tied with the help of some thread. So calculate the height to which the block rises. Also estimate the amount of heat produced in the block. So let me note down the data first. So the situation is there is a bullet of mass 0.012 kilogram moving with the velocity u1, that is 70 meter per second. Block is at rest. So u2 is 0 and its mass is capital M is 0.4 kilogram. Okay, this is the data and the situation is this is the bullet of mass m moving with velocity u1 towards this stationary block of mass capital M which is at rest. And since it is tied, since it is tied to the ceiling with the help of threads, what will happen when the bullet will become a part of this block? The block will be raised through certain height. Bullet is inside the block and it will get raised to certain height. That height we are supposed to find. We are to find that height. Okay, so this is the situation. So I'll stop here, right. Still students are entering. Okay, so what will be done here? First we will find the common velocity of bullet block system, right? So for that purpose, what will be done? Actually, this bullet was having kinetic energy and that is converted into potential energy, right? So common velocity of this bullet block system, let us find that out first of all. That will be mu1 over m plus n. Using this you can find the common velocity. Now where does that kinetic energy that this combined system has received? It is having certain kinetic energy half m plus m v square, where v is common velocity. That is converted into potential energy because of which it is attaining that height. So mgh. So our equation becomes this. This is our equation. Half m plus m v square is m plus m gh. M plus m gets cancelled on both sides. So we are getting very simple equation left behind. H is equal to v square by 2g. So just solve this. Okay, solve this. Put in the values. You have found v. Put that v here. G you know already. So you can find h. You can find the height. So very simple logic. The kinetic energy that is it obtained because of collision, it was at rest earlier. But when the bullet gets embedded into the block, it attains some kinetic energy. Okay, that kinetic energy is giving it some certain height. So that is converted into mgh. All right. So I'm going to share the next question with you. 25. Question number 25. Two inclined frictionless tracks, one gradual and the other steep, meet at A, from where two stones are allowed to slide down from rest, one on each track. Will the stones reach the bottom at the same time? Will they reach there with the same speed? So we have to find two things, same speed or same time. Explain. Given theta 1 is 30 degree, theta 2 is 60 degree and h is 10 meter. What are the speeds and times taken by the two stones? So we are to find this. Let me note down the data first. Question number 25. Read it out by that time. Question number 25. Right. So this is the situation. One plane is steeper than the other, right? A point, B point, C point. Two stones are allowed to slide down from point A. Stone 1, stone 2, let us say. Okay. And theta 1 is 30 degree. Theta 2 is 60 degree. Height, vertical height is same, though. Vertical height is though same. Okay. So let us solve this question. How much force will be acting along the plane? You know, the component is mg sine theta. This side it will be mg sine theta 1 and this side it will be mg sine theta 2. So this is the component of force acting down the plane always, right? So for both the stones, if vertical height is h, then we can say when the stones were at point A, they were having mgh, potential energy on account of that height. That potential energy is converted into kinetic energy when they reach the bottom. So we have one equation, potential energy is converted into kinetic energy. So m gets cancelled. We see that the speed is dependent upon the height because 2 and g, they are constants. So it depends upon height. And since vertical height is also the same in this case, so velocity remains the same. So yes, both the stones will fall down the inclined plane. They will reach the bottom with the same velocity. Velocity will be the same. Now we have to find the speed. We have to find time taken, right? So let us say this distance traveled is s, right? So s equal to ut plus half at square. S is ut plus half at square. They are starting from rest. Take u equal to 0. So s is dependent upon half at square. What is acceleration? How much is acceleration? That is g sine theta. Along the plane, the acceleration of the masses is g sine theta t square. G sine theta t square. All right. That means t is inversely proportional to, t square is inversely proportional to g sine theta. G is a constant. So time is dependent upon angle of inclination. So the plane that is having greater angle of inclination will be, that stone will be taking lesser time. So this stone 2 will reach first. Okay, its time taken will be smaller and time taken by stone 1 will be larger because angle of inclination on this side is smaller. So time is inversely proportional to angle of inclination. So though they will reach the bottom with the same speed, but the time taken by both the stones will be different because of different angles of inclination. Okay. So this is how we summarize both the results. I hope this logic is clear to you. Let's see next question. So I am again going to share the exercise with you. Let us see question number . Next question. That is question number 28 now. Let us see question number 28. A 1 kg block situated on a rough incline is connected to a spring of spring constant 100 Newton per meter as shown. The block is released from rest with the spring in unstretched position. You can see the diagram. The block moves 10 centimeter down the incline before coming to rest. So find coefficient of friction between the block and an incline. Assume that the spring has negligible mass and the pulley is frictionless. So let me note down what is given to us. Very less students are there in the class today, only 38, and they are coming late. Mass is 1 kilogram. This is question number 26. Okay. So mass is 1 kilogram. K, spring constant is 100 Newton per meter, and extension is 10 centimeter, 0.1 meter before coming to rest. So this is the data, and we are to find coefficient of friction. Okay, we are to find coefficient of friction mu. This is what we are supposed to do, right? So in this case, whatever work, when the block will slide down the plane, you understand the situation, when the block will slide down the plane, the spring will get unstretched. It will open up through the same extension. So the potential energy, because of change in shape of the spring, that is converted into the work. So we can say elastic potential energy of the spring, half kx square, that is doing the work. Work and energy are equivalent, you know. And work done is force into displacement. That displacement is also the same, as I told you, that the distance through which the block will slide down the plane will be same as the extension produced in the spring. Spring bhi utne hi distance ke through extend hoga. So this x will get cancelled, and we can find force from here by putting in the value of k and x that we are already having. K is 100, x is 0.1. Okay, so 5 Newton is the force here. Force is 5 Newton. Also, force is given by mu r. And in this case, when the plane is involved, r is equal to mg cos theta. R is equal to mg cos theta. So let us put in the values. Force is 5. Mu we are to find. Mass of the block is 1. Let us say g is 10, and see the value of cos 37 degrees from the tables. So you will get the value of coefficient of friction. So you will find mu this way. Okay, so this is the concept behind, this is the logic behind. All right, students. So I hope this numerical is also clear to you. Very interesting concept. NCERT numericals are also very good. You must solve these questions. So I'm going to share the next question of exercise. Question number 27. A bolt of mass 0.3 kilogram falls from the ceiling of an elevator moving down with a uniform speed of 7 meters per second. It hits the floor of elevator, length of elevator is 3 meters, and does not rebound. What is the heat produced by the impact? Okay, so when the lift is moving with a constant speed, uniform speed, then real weight is equal to apparent weight. There is no change. So they are asking, would your answer be different if the elevator were stationary? No, our answer would be the same even then, because either the lift is at rest or is moving with the constant velocity, doesn't make any difference, because acceleration will be zero in both the cases, right? So when the bolt is falling from the ceiling of the elevator, it is same situation as certain object is falling from certain height on the ground. So floor of the elevator will be equivalent to normal ground in this particular case. Let us note down the mass of a bolt, height through which it is falling 3 meters, and g we already know. So what is the heat produced by the impact? The energy that it was having at that height of 3 meters, that is converted into heat energy when it falls on the ground, that means. So what is the energy at that height? That is potential energy equal to mgh. All right. So the energy is mgh in this case, which is converted into heat energy ultimately. So here we apply the law of conservation of energy, nothing else. Okay. This is question number 27. Mass is 0.3 kilogram and height through which it is falling is 3 meter. G is 9.8 meter per second square. So the heat produced, heat energy is equal to potential energy that it was having at that height. So that is equal to mgh. 0.3 into 9.8 into 3 joules. So this will be your answer in joules. Okay, very simple. So nothing else you have to do in this question. Just you have to find the potential energy. All right. Okay, let us share the last question, fifth question, today's fifth question of the exercise. Question number 28 now. Let us see question number 28. A trolley of mass 200 kilogram moves with a uniform speed of 36 km per hour on a frictionless track. A child of mass 20 kg runs on the trolley from one end to the other 10 meter away with a speed of 4 meter per second relative to the trolley in a direction opposite to its motion and jumps out of the trolley. What is the final speed of the trolley? How much has the trolley moved from the time the child begins to run? So in this case also the running of child on the trolley itself, that is only an internal force. So it will not change anything. So the motion of the trolley will remain unaffected. As we had done a previous question, sand starts leaking on the floor of trolley. Same way, when a child runs on the floor of trolley when it is in motion, then nothing happens to it. It was moving with uniform speed. It will be moving with uniform speed because running of child on the trolley itself is an internal force, not an external force. And external forces only are able to affect the motion, not the internal forces. So it will remain the same. Okay, so we have done 5 questions of today. Now let us resume with our unit gravitation. Okay, so 5 numericals we have done, only 2 are left. We will be discussing tomorrow, right? So let us resume to gravitation. We were proving that Newton's law of gravitation is in accordance with Newton's third law of motion, right? The forces that the objects having masses are exerting on each other, they are also action and reaction forces. So we were going to prove that. So see it. Let us prove this. So Newton's law of gravitation, we were doing the properties of gravitational force. In accordance with Newton's third law. Okay, we were proving this. So we had 2 masses, m1, m2, distance between them was r, right? Force 1,2 was this, force F2 1 was this, and this was our 1,2 vector, and this was our 2,1 vector. Okay, and we had written 2 equations. F12 in vector form is G m1 m2 over r12 into r12 unit vector, and same way F21 was G m1 m2 over r21 square into the unit vector. I was telling you that the relation between 2 vectors is just that they are in opposite directions. Otherwise magnitudes are same, just they are in the opposite directions. This is the only difference. All right, so put r21 is equal to minus r12 in equation number 2. Put this in equation number 2. See, we can rewrite F21 G m1 m2 r21 square, and when I put r21 equal to minus r12 unit vector, minus we can write here. So this is equation number 3. Let us compare equation number 1 and 3. See their right hand side. GM1, M2, GM1, M2, R12 vector, R12 vector. Okay. Then R12 square, R21 square. You will think that this factor is different. No, this factor is not different. This is the magnitude. Magnitude of R12, R21 is same. Both are equal in magnitude. All right. So nothing will happen. That means we have the right hand side of first and third equation exactly same except for a negative sign. There is a difference of only negative sign. So we will say that comparing equation number 1 and 3, we will say F12 is minus F21. Okay, F12 is minus F21. So comparing one and 3, we see F12 vector is minus F21 vector, which is Newton's third law. So we were discussing concept of gravitation and we have arrived up to Newton's third law of motion. So yes, gravitational force is always in accordance with Newton's third law of motion. Okay, gravitational force is always in accordance with Newton's third law of motion. I hope this idea is clear to you. So we did the properties of gravitational force that day. So I hope this last property is also clear to you. We have proved it mathematically. All right. So after this, you can have the questions based on Newton's law of gravitation. What will happen to the force of gravitation if the distance between the masses is tripled? What will happen? In place of r, you will write 3r. So square of 3r will be 9r square. So force will reduce by a factor of 9. Obviously, if distance is increased, then force is going to decrease. Okay, but by what factor it is decreasing, we have to mention. So using the formula, we can easily tell that. Okay, so if the questions are like this, what will happen if the masses are doubled? What will happen to gravitational force? Each of the masses is doubled. So 2m, 2m, 2 2s are 4. So force will increase 4 times like this. So you can answer these types of questions. Now, if the distance between the masses is halved, what will be the effect on gravitational force then? It is halved. So put r equal to r by 2. R by 2 square. Square of 2, that 4 goes in the numerator. So 4 times. Obviously, if the distance is becoming less, force will be becoming more. But how much more? By what factor it will increase? It will become 4 times. So like this. So very small questions of this kind you have already done in 9th standard, right? So next is acceleration due to gravity, small g. After capital G, having all the information about it, we are definitely moving towards small g, which is called acceleration due to gravity. So first of all, you should know what is acceleration due to gravity. Suppose I drop this chalk, okay, from certain height in the downward direction. Then the acceleration with which it falls in the downward direction, that constant downward acceleration, why it is going in the downward direction? Why not in the opposite upward direction? Because Earth is pulling it down towards its center. Okay, Earth is a is an object of very large mass, huge mass in comparison to mass of this chalk. The mass of Earth is very, very large. Both are exerting force on each other, but whose impact will be more? The impact of massive object like Earth. So Earth is able to attract it towards it, and we can see the chalk moving downwards towards the center of Earth. We don't see the Earth moving up because of its very, very large mass. Though they are attracting each other with the same force, we just proved that they are action and reaction forces, but negligible acceleration will be produced because F is equal to ma. So the product ma will remain a constant. If mass is very large, acceleration will be negligible. So it is negligible in the Earth, so we don't see the Earth ever moving up towards the chalk. We see always the chalk moving down. So the acceleration with which Earth attracts any object towards its center, that is called acceleration due to gravity, small g. Some students, they used to call g only gravity in 9th standard. Then you were a kid, you were not aware of the logic. but now you are in +1, you are a science student, you must have clarity in your mind. So what is small g? This is not gravity, g gravity, it doesn't mean that. It is acceleration due to gravity. So write down the definition of acceleration due to gravity, small g. It is the constant downward acceleration. It is the constant downward acceleration with which an object falls towards the center of Earth. Okay, it is the constant downward acceleration with which an object falls towards the center of Earth. And this acceleration due to gravity does not depend upon mass of falling object. Okay, all the falling objects, they will fall at the same rate. Have you heard of Galileo Galilei's experiment? He did coin and feather experiment. He allowed coin and feather to fall in air first of all. Then who reaches first at the bottom? Obviously the heavier one, the coin. So we think that acceleration due to gravity depends upon mass. That is why coin is falling earlier. But no, it does not depend upon mass. He conducted the same experiment in vacuum then. Then both the objects, they fell on the ground at the same time. That means acceleration due to gravity does not depend upon the mass of falling body. So I'm going to show you one experiment that was conducted live to prove this concept, Galileo Galilei's experiment. Maybe sound is not heard. So he is standing in a big arrangement, big vacuum chamber. Right now the vacuum pump is not switched on because he himself is standing inside it. So that means air is present. So they have made the arrangement of a heavy ball and a feather, very light object, feather. So in air, when they are allowing both of them to fall simultaneously, let us see who reaches first. Obviously the heavier ball reaches the ground first. But then they create vacuum inside. So he will be standing outside, and in vacuum we will observe which object will fall earlier. So after some time, now they are creating vacuum inside. They have turned on the vacuum pump. This shows that acceleration due to gravity does not depend upon mass of falling object. Let us see. Yes, they fall simultaneously. Okay. So this was Galileo Galilei's experiment. In the same way he conducted long back, right? So is that clear, students? Any doubt if you are having, you can ask. Tomorrow we will be deriving expression for acceleration due to gravity. Small g is equal to gm upon r square, and variation of acceleration due to gravity with certain factors. 9th में आपने किए हुए हैं, but now a little bit of higher level we will be doing, and numericals also we will be doing. I have sent the assignment of work, energy and power today in your class WhatsApp group. So try solving those questions. I'll be sending you the key also after a few days, but first you try yourself. Yes, students, any doubt if you're having, you can ask now. Any doubt from today's lecture? Students, you can ask. Yes, students, any doubts? You can ask.